All right, there you go. I hope you all had a lovely weekend. Boy, that was quite a good snowstorm we got, eh? I was expecting, a little annoying half an inch thing, and we got that beautiful northwest Wyoming snow where the wind doesn't blow and it falls straight down. Wasn't that nice?
We just got rain.
Just rain, huh? Oh boy, we got socked. We got probably 5 inches of snow. It was beautiful.
Yeah, rain, and
Right. What a gorgeous snow. We don't get that but maybe once a year where it actually falls vertically like normal people's snow. Our snow is like sideways snow, but not this time. It was great. It was hard to shovel though, wasn't it? Did you guys go out and shovel that wet, slushy snow? Every scoop of snow was like super heavy. But your trees and your yards are going to be so happy when all that melts off. Are you guys all done copying? Not bless you. When we copy the next example down, I'll try to give you some pointers as to how we can copy just the important details so that because I don't want to take 5 minutes every time. I mean, I know it's annoying for you, but it's also inefficient use of our time. So we'll get enough into our notes on the next example where we can just kind of have the gist of what's going on, right? So I'm going to go ahead and get to it. So the goal obviously is at the end. You'll with word problems, you'll normally figure out that whatever someone wants you to do is in the last sentence, quite frankly. That's not a golden rule, but I'd say almost all the time, whatever anyone wants you to find, like, okay, so what's the math question? It's usually going to be in the last sentence. So the goal for us is to figure out how much a rose bush costs and how much a geranium costs. All right. And so you'll see here that we're going to use the two different people. So like Cody is going to create an equation for us. Danielle's going to create an equation for us. And because they shopped at the same store, then we can put them together into a system. Like it wouldn't do us any good if they shopped at different places, right? But because we know that like Cody paid the same for rose bushes as Danielle and same for geraniums, then it'll be a system like they're at the same place. So I'm just going to teach you this. And if we don't need all three examples, then so be it. But um, there's a 4-step process for this that I am not going to really budge on at all. Um, so the first step is to declare your variables. So I'm going to write that down for you. So step one, and I say your variables because honestly, at this point in the problem, there are no variables, right? No one has them. You haven't created them yet. And so in fairness, even if you use variables that make sense, like I think for rose bushes, I would probably let my variable be R, right? And for geraniums, I'd probably use G. But that doesn't, you know, excuse us still from declaring them. And any, whether we do this in Delta Math or a district assessment or anything, someone will want you to tell them specifically that these are the letters I'm going to use and this is what they stand for. So get used to this. You're not going to wiggle your way out of this or negotiate your way out of this. This is an expectation for all teachers across the board, is that we need you to tell us what your variables are and what they stand for. So usually for this, we're going to use the word let. It's just a common thing in mathematics. So we're going to say something like, let R equal the cost of a rose bush. When I grade these, you'll be taking a quiz on this in a week or so. And when I grade your quizzes, I will grade the 4-step process. I will grade every step of it worth points. And so your variable declaration will always be worth 2 points. So make sure that you do it, whether you feel like it's necessary or not. So I've declared that I'm going to use R to represent the cost of a rose bush. And I also have to do a second declaration and just tell the world that G is going to represent the cost of a geranium. I get this question after we get settled in. People usually say, do I have to use those? Can I use like X and Y? And the answer is, of course, use whatever you'd like. I generally try to stick to contextually appropriate variables, you know, when I can. The ones I tend to avoid are like if it's the cost of a jar of olives, I might not use O for olives. Why do you think that is? Right, it starts to look like a zero eventually. And there are other variables that you'll just find that maybe you don't like to use. Like if you make sloppy T's or sloppy pluses, you might want to avoid using T's because you might think they look like pluses. So you do have some freedom here, but you'll find that I pretty predictably use variables that just make sense in the context of the problem. But you use whatever you like. And that's the beauty of declaring them is, you know, whatever you use, just make sure you tell somebody what they are. So any questions on step 1? Okay, I'm going in now and I'm going to make a math problem. So step 2 of the 4-step process is to write a system. And a system is going to consist, in this case, of 2 equations. The first equation will come from Cody. And I say Cody because I feel like Cody is the first person mentioned in the problem. And so I just think that logically I should start there. You don't have to. But. So this equation isn't going to have the name Cody in it. It's just going to be a representation of basically, here it goes, like how much Cody spent on rose bushes plus how much she spent on geraniums has to equal how much she spent total, right? So let's throw this out. Anyone want to hazard a guess as to how much Cody spent on rose bushes? No, she spent 122 total. And I know that the wording of that could be a little bit confusing, but the $122 wasn't just rose bushes, right? That was her total. When she checked out at the counter, her total came to $122. So how much just on rose bushes did she spend? Nope. Okay, let me ask you this. How many rose bushes did she buy? Okay, and how much does each one cost? See, that is a great answer. We get used to, in algebra, if we don't know what something costs, we've already got a variable, right? And if you think about it, when you have a number of things that you buy and a cost of each item, how could you calculate how much you spent on that item? If I bought 4 jars of pasta sauce and it cost $3 per jar, how much did I spend on pasta sauce? 4 jars, $3 a jar, $12. What if I bought 5 bags of cookies and each bag cost $2? How much did I spend? What is your brain doing when I ask you these questions? Exactly, it's multiplying. So let me ask you this again. How much did Cody spend on rose bushes? How many did she buy? How much does each one cost? R. So how much did she spend on rose bushes? That's the best answer of the day. That's what's going to get us going right there. She spent exactly this much. And that's new and different for us. We're like, what? It's not a number? No, of course it's not a number because we don't know how much the rose bushes cost. But we know if she bought 7 of them and they cost R each, that she spent 7R. We don't know what R is. That's called a variable quantity. Now I'm going to add to that because she didn't just spend money on rose bushes, right? Now that you kind of see that secret, that cat's out of the bag, how much do you think that Cody spent on geraniums? How many geraniums did Cody buy? And how much did each one cost? So 12G is how much she spent on geraniums. Now, the first thing, the 7R represents the cost of rose bushes. The 12G represents her cost for geraniums. If I add those together, what do they have to equal? Thank you. This is the money that she spent. Don't write that down unless you want to. That's the money that she spent on rose bushes. That's the money that she spent on geraniums. How much did she spend altogether? $122. So if you're inclined to want to say 19, bear in mind you can't do that because those are not like terms. So there we have, for the first time, our equation. Equation number 1 of the system. Now, if someone said to me, solve that, I literally would tell them I cannot. And a math person would never ask that of me because at this point, there are literally infinitely many combinations of costs for rose bushes and geraniums. So one equation with 2 variables is not enough, hence the need to have a system. So now Danielle comes to the rescue. So let's take a look now at Danielle. How much did Danielle spend on rose bushes? Nope. I heard 58, and it's not 58. Again, she did not spend 58 on rose bushes. She spent $58. Say it again. She spent 2R. How many rose bushes did she buy? How much does each one cost? R. 2R is how much she spent on rose bushes. That 58 is not the cost of rose bushes. That's how much Danielle was charged when she went to the counter with her rose bushes and her geraniums in the cart. How much did Danielle spend on geraniums? Now that felt like it went a little bit better that time. There you go. And how much total? Bless you. Yes. And there's our system of equations. I'm glad to hear you say that. And I think once you get the hang of it, you'll find that this isn't bad at all. So step 1, let's recap, was to declare our variables. You don't have to like it, but if you want full credit, you got to do it. Step 2 is to use those variables to write a system of 2 equations. You want to guess what step 3 is? Solve the system. Very good. So step 3 is to solve the system. And this is where our practice from last week and the week before come in handy, is that now we shouldn't have to have some long drawn out conversation about how did you do this, how did you do that? Because assuming that you do your work in this class, you've done tons of practice on solving systems. Is this system well suited for substitution? It is not. In order to be well suited for substitution, I would look around and find the variable that doesn't have a number with it. And I hate to tell you, but really none of them work, do they? All the variables have numbers stuck to them. So doing substitution here would really be an unwise path. You could do it, but it would kind of suck. So let's go with elimination. So now I've gotten the word problem scrolled up off the screen because for the next couple of minutes, we're not really doing the word problem. We are just doing math, right? We're using mechanical skills to accomplish a task. So of the 2 variables, which one is more attractive to you to kill, the R's or the G's? The G's that's the right answer in this case. Why? Because you only have to multiply one of the equations instead of both. Listen, if you want to do the R's, could we turn both of the R's into 14s? Sure. But I look at the G's and I'm like, I'm pretty attracted to that 6 down there. Because I could real super quick just multiply that bottom equation by not 2, -2. Very good. Beautiful. So what I'm going to do now is I'm going to take the top equation from my system and I'm just going to copy it over. So I have 7R plus 12G equals 122. And now below that, I'm going to write down the modified, the multiplied by -2 version of the second equation. What's that going to be? Yep. G equals, when you guys multiply numbers like this, remember, just break the bigger number in parts. Break it into 50 and 8. Yeah, and multiply them both by 2, right? 2 times a number is 2 times his pieces. So 2 times 50 is 100, 2 times 8 is 16. Smack them together, you get -116. And there we have a level 1. So that system could have been viewed as a level 3 if you opted to go for the R's, but we made it a level 2 by making a good choice. And now we got it down to a level 1 fluffer puffer. So when we add straight downwards, how many R's do we get? Good. When we add straight down, how many G's do we get?
0.
Of course, none, right? That's the whole point. And then what's 122 plus -116? Definitely 6. Divide both sides of that little baby purple equation by 3, and what do you get?
It's hard to see.
Okay, wonderful. Now let's plug that back in. We're still not in word problem mode right now. That's what step 4 is, to return to the land of word problems. Step 3, we just got our sleeves rolled up and we're just in there doing math, right? So R does me no good if I don't know G. And how do we find G? Say it again. You both said, I didn't know. What do I?
Why do you put that all into
Sure. Yeah, you can insert the R value of 2 into any place that you want to. You could insert it anywhere you want where there's an equation with 2. I think that Alana's probably right that we should go into the green equation just because the numbers are small. But you could go yellow equation, green equation, or even the bottom white equation if you were feeling crazy. But the green is probably going to be the simplest for us. So when I insert the 2 back up into there, I'm going to recopy the green equation now, and it's going to say 2 times blank plus 6G equals 58. And what's going to go in that blank? The 2. And then, as always, we hope and pray that August and September went well so that we don't get bogged down on goofy stuff like this. What's 2 times 2?
4?
4. So we have 4 plus 6G equals 58. What do we do next? Correct, which gives us 6G equals, divide by 6, giving us, good job. This is not an appropriate time for you to write your answer like this. Because we're not just doing a math problem here. I'm not just looking for a place on the plane where 2 lines cross. So please do not express your answers in word problems like this. That does not mean anything to anybody. So this is where step 4 now rears his head and says, okay, you did a good job. You got buried there in the forest and you did a great job. You did some math. You figured out RNG. Step 4 to the rescue. Step 4 is answer the question. And this step involves the use of the English language. So for those of you guys that struggle with that, this is a good opportunity for you to practice with the basics, capitalizing sentences, putting periods at the ends of sentences, things like that. Spelling. All right, let's practice good, proper grammar. So here it goes. At this point, to answer the question, I can say this: a rose bush costs how much? $2. Label it, period at the end of the sentence. Okay. I can also state now, a geranium costs how much? And that completes the 4-step process. So let's recap again. What was step 1? Declare your variables. Use whatever you like, but for God's sake, tell everyone what they are, what they stand for. What's step 2? Write a system. Make the math problem, right? What was step 3? Get in there and do the math. What's step 4? Answer the question using proper English. All right, these steps are non-negotiable. I've been around this particular neighborhood a few hundred times, and I'm just sure now that this is just the way to go. Follow those 4 steps and you're golden. Yes, ma'am.
Like on this one, like what happens if like we would have gotten like a negative and it like doesn't like make sense, like a rose bush kind of cost like -$2.
Yeah, you know what? People don't ask that question a lot, and I'm really proud that you did because that is a superstar question. Let's talk about that. Well, first off, let's assume that your math teachers are not going to write you questions that are bad. But now, being a human, I might on occasion make a boo-boo. But the computer wrote this one. So let's assume like you're taking a test, you know the question's been vetted, you know it's a good question. What do you think would go through your mind if you got that the cost of a rose bush was -2? You did something wrong. Very good. It's kind of the same as those worksheets where I give you them and I tell you you shouldn't be getting fractions, right? It's like a clue. And if you get a fraction, you're like, oh boy, I got to go back and figure out where I boofed it, right? So if you get a negative here, you know that that can't be correct, right? So you would go back at that point and say, okay, where did I go wrong? That's a great question. And as always, if you were feeling very, like go-getter kind of, how could you make sure that these answers are correct? Right. Go back to the problem and check and see if Cody and Danielle, by the numbers of plants that the problem said they did they correctly spend $58 and $122? And if it works, then you're like, jackpot, baby. So it's one of those times, anytime you're working with equations, you can always check your own papers, which is nice. Let's do one more. I don't think you probably need 2 more. And let's try as we copy this one down, maybe we can be a little bit more concise with, instead of copying every word, let's just kind of copy down the meat and potatoes part of it. Okay. You guys want to do the one about cookie dough? Or do you want to do the one about vans? Gee, why would you pick that one? No, what's fun about this is none of them are hard. Like Addie nailed it early. This isn't bad. The key is to follow the 4-step process. I will not give you any today that go outside the box, the comfort box. There's going to be 4 types of problems you'll see. And if you can listen while you, again, don't write down every word, just try to get the gist of it. There's going to be problems about vans and buses like this. There's going to be problems about people doing gardening and buying their supplies at the same store. There's going to be problems about people selling tickets to like a school concert or a play or something like that. And then there's going to be ones about, I think, people doing fundraisers. Yeah, like selling wrapping paper and cookie dough like you just skipped past. The worksheet that you'll have, then we'll work on it today, but we'll also work on it tomorrow, has 8 problems. And honestly, it's like the same 4 problems on the front as it is on the back. You know what I mean? Like the same 4 scenarios, just with different numbers and different names, stuff like that. So for the sake of your notes, you could just put like for school A, 4 vans and 1 bus was 91 kids. For school B, 12 vans and 12 buses was 552 kids. You know, so hopefully we can be a little quicker through this part.
All right, I'm gonna pour a fresh cup of coffee and then we're off and running, okay?
And if you want to jump ahead, you're welcome to. Go ahead and get started on step one.
Make sure you do not cut corners in step one. Like, for example, you can't say, like, let V equal Vans, right? That's a ghetto, terrible thing to write because that's not enough information. So let's get into it. Step one. So step one is to declare our variables. And so I'm going to say, let V equal what? Yeah, don't say vans, because vans can mean the weight of a van, the amount it costs to paint a van. So we're just going to say that, by the way, in this problem, it's very critical that you read the sentence that I'm underlining in red. And that is that the vans that school A and school B use hold the same number of kids. So that has to be consistent, kind of like the Danielle and Cody problem, that they're shopping at the same store. If school A and school B use different types of vans and buses, this wouldn't be a math problem at all. It would be a guessing game. So it's important to represent or to acknowledge that V is the same for school A as it is for school B. And we want to be specific and say, let V equal something like number of students in a van. Okay. If you put let V equal vans, rest assured that you will lose points for that because that could mean hundreds of different things. All right. What is our other variable going to be? B. And this is where you have to be really careful. If you're someone whose B's look like sixes, you might want to bail and use something instead of B for the buses. All right, that's up to you. Obviously, we'd love it if our B's didn't look like sixes, but even mine, I do this for a living, and even mine, sometimes kids say, is that a six? And, you know, it is what it is. So I'm going to go ahead and stick with it. Let B equal the number of students in a bus. Step one, done in the books. Now, school A is going to produce one equation. School B is going to produce the other equation, and there will be our system for step two. So can anyone give me an equation for school A? Say one more time, buddy. I can't hear you back there. Well done. So 4V, that's 4 vans at a capacity of what we don't know yet, plus 1B, and I'm just going to put B instead of 1B. I'm not a big fan of those silly ones, equals 91. Again, at this point, there's a lot of possibilities. There's not as many possibilities as there were with the Rosebush problem because you can't legally cut kids up into pieces. So like a van, we could not say holds 13.96 kids, right? Like that's illegal still, I think, in like 46 states. Like you can't do that. But because they're whole numbers, there are still a boatload of possibilities, right? Like a van could hold 2, and that would leave a bus holding 83. A van could hold 3, and that would leave a bus holding 79 or something like that. So at this point, again, that's not enough information. I need a second situation. What is school B's equation? You got it. So 12 vans plus 12 buses equals 552. Now, I'm going to ask you this like I did last time. Is this equation system suited for substitution? This one is. So to make our notes a little bit more comprehensive, let's go with substitution this time. I would not, for the record, like if I were doing this on my own, I'm a elimination guy, but let's try something else. So let's go with substitution. Let's take this top, we're in step 3 now, right? Now we're rolling up the sleeves, going in and getting her done. Let's take this top equation and let's solve it for B, because why not? The opportunity presented itself and it won't often. So what would that top yellow equation be if I got B by itself? What would it say? B equals what? Negative 4V. Yeah. And as I always have done, always will do, I am going to draw the box because I'm using substitution. So this is the box method where I say, okay, inside that red box is a bunch of stuff that equals B. So what can I do with the contents of that box? You got it. Very good. If that's what B equals, then I can put it right where this little red arrow is pointing right there. And remember that with substitution, you're limited. If you use the top equation to make the box, you cannot go back into. He's out of play for a little while here. So I'm now going to take the green equation and I'm going to rewrite it like this: 12v plus 12 awkward void equals 552. What's going to go into the awkward void? Good job. And that's the beauty of substitution. Is just like elimination, we got to get to a point where we only have one variable that survives. Whether we substitute or eliminate, we got to get there. So now we're going to distribute, and that's going to be 12v minus 48 b's plus, oh my, 12 times 91, that's 910 plus 182, which is 1092. You might want to check my math here. It's a little early on a Monday for me to be doing double-digit multiplication. 12 times 91. 1092. Okay, good. Okay, well, hey, I shouldn't be trying stuff like that until midway through the day on Tuesday. So, all right, we made it. And at this point, when I add my V's together, how many do I get? What is 12 V's minus 48 V's? Say it again. I won't stand for that. It is negative 36 V's. And then we have to, and listen, going back to something that Addie said a little while ago, should I be concerned right now that there's a negative on that B? Not yet, right? Because it's going to probably just all come out in the wash here. Let's let this run its course and see what happens. So what am I going to do next? You bet. I'm going to subtract 1092, and that's going to solve our little negative dilemma, because the last I checked, you can't take 1092 away from 552 without using negative. So negative, rescuing other negative, eventually dividing, making a, okay, good. So we're going to be okay. What is 552 minus 1092? Negative 540. And the last step is, of course, to divide by negative 36. What is V? 15. Oof, we made it. And that would be the type of problem where I would want to be on the lookout, not just for a negative at the end, but also a decimal, because a van, no one would say, oh, the van holds 15.2 kids, right? Like that's, again, just weird. So I like that it's a whole number. I wouldn't have been concerned with a decimal on the Rosebush problem, because like, what's to stop a place from charging 2.43 for a Rosebush, right? That no problems there. Yeah, but a decimal here would cause me concern. So 15 kids per van. Now we have to figure out B. And for substitution, I am never going to overlook the beauty that is the box. So I'm going to take my 15. I'm not going to ask for your input on this, and I'm going to put it right where that purple arrow is. You got the box, dudes. Use it. Right. So over here, I'm going to do B equals, that's negative 4 times 15 plus 91. What's negative 4 times 15? Yeah, it's right there, negative 60. I'm just putting the 15 back up in the box, guys. The red box, remember, he's your best buddy in this substitution. The box is your ally. So if I put 15 up there, I get negative 60 plus 91. And what does that equal? 31. So I just figured out the answer to the math problem, not the word problem. So now we emerge, we come out of the forest of mathematics, and we answer the dang question. So using complete sentences, here we go. A van holds what? 15 students. Very good. That is a pretty big van, isn't it? Capitalize the beginning of your sentence, period at the end of your sentence. I am not your English teacher, but we should all strive to speak and write proper English, it being generally our native tongue. So don't give me any grief about busting your chops if you're doing ghetto English, because I'm going to call you. A bus holds 31 students. Put a box around that son of a gun. I bet at this point you guys are probably okay to be done with the notes. Is that a safe assumption? Okay. Well, I'm going to hand out today's assignment. We are going to work on it today. Your goal for today should be to see if you can get 2 problems done. All right, 2 out of 8, and then the rest we'll work on tomorrow. Deal? All right. Let me end this recording.